Welcome you guys to today's discussion class. This is going to be the day one for the 500 questions in chemistry that you must know before writing your JAMB. So let me see how I can share this on a WhatsApp status. We said 8 o'clock, just a few minutes to that, and then we move. All right. All right. We are back. Let's set the camera well. Okay. You're welcome to the Majestic Tutorials. In this live stream, we'll be handling this chemistry questions. Remember to drop your questions. Where you drop your questions should be, you drop your questions at Daily Science Quiz 4. Maybe you want to send in a question, send it at dailysciencequiz4@gmail.com. I think from that we will read that. So we'll be looking at some past questions as we wait for your questions. I've dropped the link to the WhatsApp group, and then also the email where you send in your questions. All right. So if you can hear me, you send in message. Let me know if I can receive message, because so there are questions we'll be using on the background. These are the chemistry questions I'll be handling. You are here not to just get the answers. The main aim for joining the live stream is to learn the cheats on how to get the answers to the question fast enough. So this is the question I'll be using for this live stream as I wait for your own question or questions. So please you drop your question at maybe I'll write it on this script, Daily Science Quiz 4@gmail.com, if the question is in image form. But for now, looking at question number one says chlorophyll obtained from green leaves of plants can be shown to be composed of more than one colored component by the technique of, since they say chlorophyll, it is colored. So anytime you hear chloro, you talk about chromo, because the word chrome is about color. So even in exam, even when they say another color, maybe a sample of a sample of tobacco is suspected to contain different colors, or if they say a given ink have different colors, immediately they mention color, ink, pigment, how to separate them, you use chromatography. So in case of next time, the correct answer to this question is chromatography. For you that is watching, if you are there, you can say hi. Let me check if I can still receive message. If you are on, for those that are on now, you can send in message. Let me confirm if I can receive your messages, because sometimes this messaging thing hooks. All right, let me proceed. I can't see any of the message. Now we look at number 2. Says in countries where the temperature falls below 273 Kelvin, Salt is always sprinkled on the icy roads in order to, what's the aim for sprinkling the salt in the icy road? This one is to lower the melting point, because impurity generally lowers melting points. Impurities generally lowers melting point, which means the correct answer to this question is it doesn't raise the melting point, lowers the melting point. Option A is correct. So to throw more light to this, the freezing point of water is 0 degrees. So at 0, water is expected to be solid at that moment. But if you introduce impurity, water will not freeze at 0, it will freeze below 0. So that's what it meant by the fact that the freezing point, that impurities lowers freezing point. So in icy roads, for you to assess the road, the cost of heating the whole environment is higher. So what scientists do or chemists do is to introduce impurity, and the impurity is in form of salt. So they sprinkle salt. This time around, the type of salt is not a problem. As far as there is a salt, it will act as impurity to lower the melting point. Now, impurities lowers melting point, but increases boiling point. So impure water boils above 100. So that's the secret you learn about this. I'm worried for not receiving any message. That means maybe there is some problem in the host of, and I don't like this when it happens. But let me proceed. I believe maybe with time. All right. So the next question is, remember what I explained in question number 2 is called colligative property. Colligative property, when you grow higher above that JAMB level, you know them. They are the properties that depends on the concentration and not on the nature of the solute. That is freezing point depression, boiling point elevation, which is what they asked here. Then question number 3 says, question number 3 is all about calculations, okay? And then they say from the equation of the reaction, and we can see clearly the equation of the reaction, calculate from the equation of the reaction above, calculate the mass of sodium hydroxide produced by 2.3 grams of sodium. 2.3 grams of sodium. This, you can solve this without wasting time. There are certain things you need to know before you go for exam. Like, you know the molar masses of some compounds. They have said sodium hydroxide. You should know that sodium hydroxide is 40. The molar mass of sodium hydroxide is 40. The molar mass of that of sodium chloride is 58.5. Molar mass of sodium triazoxide carbonate 106. Molar mass of copper 2 tetrazosulfate 6 is 160. You must know all these things so to avoid making mistake. H2SO4 is 98. Okay, potassium hydroxide is 56. So with this fact, you can now save time. They are talking about sodium hydroxide here. You already know it is 40. Remember, they didn't write the formula for you. So if you don't know it ahead, you waste time in solving questions. So what we are going to do is look at the equation. Look at what they gave us. They say calculate the mass of sodium hydroxide. So we are going to look at given and calculated for. The one they are calculating for is sodium hydroxide, which is here in the equation. Then they gave us sodium. Look at it. Sodium is here, and this is sodium. So in this equation we are seeing, we are going to be relating only two, which are sodium and sodium hydroxide. Sodium and sodium hydroxide. Because the question says calculate sodium hydroxide, you go and pick it from the equation. Then look at the one they gave you the value. It must not be mass. It can just calculated for and the one given. So the one given is sodium. So from the equation, 2 moles of sodium will give us 2 moles of sodium hydroxide. You write it out. The given and calculated for becomes our concern. 2 moles of sodium gives us 2 moles of sodium hydroxide. Since they are 2, it means you can easily cancel because they are equal, which implies that 1 mole of sodium will also give us 1 mole of sodium hydroxide. When you do this, ask yourself, what is the unit they ask you to calculate this? They say the mass. So you must change this sodium hydroxide to mass by finding the molar mass, which I told you is already 40. If you don't know, you look at what was given in the bracket. What was given in the bracket, they told us that hydrogen is 1, sodium is 23, and we have NaOH. So anywhere you see sodium, you put 23. After that, you put plus oxygen, you put 16 plus 1. So this will amount to what? 40 gram per mole. That is the mass. We are going to convert this sodium hydroxide to mass because they are asking us to find it in mass. All right. Then you convert also the sodium hydroxide. I mean the sodium. The sodium was also given in mass to 2.3 grams. And molar mass of sodium is, so we convert this 1 mole to masses, which means 23 grams, that's what they gave us here, will give us 40 grams of sodium hydroxide. And they are asking us 2.3 will give X. You don't need to solve this type of question in exam. What you have to do is simple. Just do what? You see that the numbers are the same here, 23 and 2.3. This is what we call division factor or shifting. Remember that it means 23.0. They shifted the point here. So come here and also shift the point. 23 gave us 40. 2.3 will give us 4.0. So in this case, we have, but if you don't know, you still do you call it X and call it whatever if you still have time. So looking at this, for you to solve, you have 23x. Maybe I keep this here. Get the note here. I think where I can write. For not receiving any message shows, maybe I don't know what to do so I can see your live chats. Now, what I'm saying is 23 to give 40. 2.3 will give what? X. If you watch this number here closely, they are the same thing, only that point shifted. 23.0, they shifted the point here to get this. So you come here and also shift the point. That is 4.0. All right. So, or you still follow the normal order of calling X. It becomes 23X is equal to 2.3 times 40. Divide both sides by 23. Divide both sides by 23. So this is automatically 0.1, and 0.1 times 40 is still 4.0. So looking at this question, the correct answer is option C. All right. We go to the next question. The next question says, still calculation. 16.8 is not all that too clear. 16.8 grams of sodium hydrogen trioxocarbonate 4. 16.8 grams of sodium hydrogen trioxocarbonate 4 is completely decomposed by heat. Calculate the volume of carbon 4 oxide given off at STP. All right. The same thing happens here. We are writing equation. This particular question is a bit harder than the previous one I just solved. Why? Because the previous one, they gave us chemical equation, but this one, there is no chemical equation, so you have to forge one by yourself. So the chemical equation is, we were told to get maybe I can lift the question here anyway. Okay. So this will help 16.8 grams. So we'll be seeing it and also be solving 16.8 grams of sodium hydrogen triazole 4. Can get the answer without looking at it because 84 is the molar mass of sodium hydrogen triazole 4, which I taught you that knowing the molar masses of certain compounds, at least 30 compounds should be in your head so that you'll be able to answer some questions without delay. So 16.8 grams of sodium triazole 4 completely decomposed. Okay, the composition. So we write the equation for the decomposition, which is NaHCO3. Action of heat will give Na2CO3 plus H2O plus CO2. So this is the equation, and to balance the equation, because sodium is 2 here, we put 2 here, and that will there balance the equation. You now go back and check the related species. What are we calculating for? They say carbon 4 oxide, volume of carbon 4 oxide. So we go to our equation and pick CO2. Then what was given? Sodium hydrogen triazole 4, and that is 16.8. All right. So our interest now is only on the 2 species. Remember, it's only 2 species that must be related, given and calculated for. We are calculating for volume of CO2 at STP, and this was the mass they gave us. So we are going to convert these 2 moles of sodium hydrogen triazole 4 to mass, and convert this 1 mole of CO2 to volume. Why? Because they say calculate the volume. But this one, why should I convert the 2 mole to mass? Because it was given in mass. Assuming it was given in moles, I will use these 2. But the question gave it to us in mass, 16.8 grams. So I must speak in the same language. Let the equation you wrote rhyme with the units in the question. All right. So by doing that, you have to calculate the molar mass of sodium hydrogen triazole 4. Sodium is 23. I already know it's 84, but let me calculate. Plus 1 plus 12 plus 48, because 16 times 3 is 48. So looking at this, we have 24 plus 12 plus 48. You can do horizontal addition, which means 4 plus 2 is 6. 6 plus 8 is 14. You now carry what? 1. This is 3. 4 plus 4, 84. So 84 is the molar mass of sodium hydrogen triazole 4. When you multiply it by 2, because there is 2 behind, if you multiply this 84 by 2, you will get 168. Do you understand that? You see how JAMB question works? So instead of me writing 2 moles of sodium hydrogen triazole 4, I'll write 168. I already know it's 168 because 2 times 84, 168 grams. I'm converting this thing to rhyme. Will give me what? 1 mole of CO2. 1 mole of any gas at STP will occupy 22.4 dm cube. Now, the mass they gave me is now 16.8 grams. Will give me X. You don't need calculator here. You do the same thing I did in the first one. You shift point. Remember that 168 means 168.0. So, do you know what they did? They shifted this point, shifting of point. They shifted it backward to get this. So, come here and also shift this point here in the same direction so that you get 2.24. This is only applicable if the numbers are the same, 168, 168, but they differ only in the position of the point. Am I making sense here? But when they are not the same, don't apply this majestic division factor or shifting point factor. So without wasting time in JAMB, you don't need to go and press calculator. If 168 give me 22.4, 16.8 automatically gives me 2.24. Let me check if you have learned this anyway. if we have, what if the question says now 168 gave 22? I am assuming we have gotten our answer. What will 0.168 give? 168. Do you know these points here was shifted 1, 2, 3 to get this? So you come here and shift. This is the position of the point. You shift it here. 1, 2, 3. You fill it with 0. So it becomes 0.0224. That's what it will give you. That is a way to save time. Maybe I'll take the easier one. For instance, if we have that 12 gave 32.5 grams, and in exam they now asked you what will 1.2 give. Very simple. You find out that the point was shifted just one place behind. Come here and shift it. Shift this point here. It becomes 3.25. That's your answer. To save time, no need of pressing calculator. So we go to the question. So the answer to question 4 is option C. We go to question 5. Sorry, these things are blurry. They say 300 cm cube of a gas has a pressure of 800 millimeter mercury. If the pressure is reduced to 650 millimeter mercury, find the volume. Honestly, I know your messages are coming, but unfortunately I can't see them. Okay, I don't know why it's not popping up on my screen. Sometimes it behaves that way, but I believe next live stream it won't be like that. Okay, 300 cm cube of a gas. This is all about gas laws, and is talking about volume and pressure. Temperature was not mentioned, which means Boyle's law applies. So Boyle's law applies because it's relating volume and pressure, and the only equation that relates volume and pressure is Boyle's law, which says P1 V1 equal to what? P2 V2. Now, according to Boyle's law, if you know Boyle's law, you don't even need to solve this question. That's why you are here, because I know you have your past questions that have the answers. So if I don't give you the cheats, there is no need. According to Boyle's law is trying to tell us that when pressure increases, volume will decrease. And when volume decreases, pressure will increase. That's what we mean by inverse proportion. It states that the volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. It implies that anytime volume increases, pressure will decrease, and anytime volume decreases, pressure will increase. So watch this thing. You can reason it and shade your answer and go your way. Watch the first volume, 300 cm cube. The second volume is now what? That's what we are calculating. Okay, the first pressure was 800 millimeter mercury, then the second was 650. You see that we moved from 800 to 650. So 650 is less than 800, which means pressure decreased. And if pressure decreased, volume will increase, meaning our V2 must be more than 300. Our V2 must be more than 300. If you come and look at the option, A cannot be answered because A is below 300. Then they made it difficult by giving us B, C, D, which are all above 300, but no problem. See what you have to do. 800 millimeter mercury is not quite far from 650. It's just 150 difference, which means it's B that is depicting it, because 738 is almost multiplying by 2, but the pressure wasn't decreased by half. If pressure is decreased by half, volume will increase by 2. That is inverse proportion. So with this, B is going to be the answer. All right, by direct reasoning, meaning because pressure decreased from 800 to 650, volume must be above, V2 must be above 300. So anything Boyle's law, Charles' law, majestic students, you don't need to waste time solving it. All right, so let's see the calculations. Normal, we are looking for V2 abi. So we are looking for V2 from this question, which puts us to the formula. our V2 now will be equal to P1 V1 over P2. And P1 is 800, if I'm not mistaken. P1 is 800. Our P1 is 800 times our V1 is 300 divided by P2, which is 650. Cancel, cancel. We are left with 800 times 30 divided by 65. This is a very way of a long way, wasting more of your time. So looking at the calculator here, we are dividing what? 800 by 30 divided by 65. Okay. 800 by 30 divided by 65 is equal to 369.231, which is, that's option B, I said. All right. Let's see the next question, number 6. Diffusion is slowest in solid particles than in particles of liquids and gases because option A says solid particles have more kinetic energy than the particles of liquids and gases. B says solid particles have less kinetic energy than the particles of liquids and gases. That's a fact, but check other options before you can choose. C says solid particles have less restrictions in their movement than liquid and gas particles. Option D says the particles, that C is incorrect too. Solid particles don't have less restriction. It has more restriction instead. Then the particles in solids are far apart and the cohesive forces between them are negligible. It is not true. So this is all about kinetic theory of matter indirectly. It is only option B that conforms with reality. Solid particles have no. Solid particles, yes, have less kinetic energy in motion. They don't move. This my whatever this pen I'm using is solid and is you can't see the particle at this edge move freely to this edge, so it doesn't have free kinetic energy and hence it will delay diffusion. That's the only thing that is fact there. Then question number 7 says the experiment that showed that atoms have tiny positively charged nucleus was first carried out by Ernest Rutherford through his two students, Gige and Marsden, if I can get the spelling correct. Marsden. Gige and Marsden carried out the what? The alpha scattering experiment. It was the alpha scattering experiment that led to the discovery of the nucleus and the proposition of the theory of an atom to go against Thomson's model by Rutherford. Actually, it was his students that carried out this experiment first, but he takes the credit. What is the experiment that led to the discovery of the nucleus? I said it is the alpha scattering experiment. So the alpha scattering experiment was carried out by the two students of Rutherford, Gage and Marsden, but it was their boss, Ernest Rutherford, that gave it correct interpretation. So he discovered that most of the alpha particles passed undisturbed and some were deflected at large angle, some were thrown back. So that do not conform with the plum pudding model according to John Joseph Thomson. And Rutherford was like, no, the positive charges are not scattered everywhere, rather they are concentrated at a point. It is at that point where they are concentrated that deflects the so-called, I want you to get a concept. Before alpha scattering experiment, this is how scientists saw atom. That's the plum pudding model, that atom is made up of scattered positive charge all over with negative charges embedded in it like a plum pudding. We call this thing the pudding model. All right, sorry for the delay. We are back. So, as I was explaining, that this was how scientists or chemists saw atom. Remember, these ones I put in circle, maybe I would have used different colors. Please, these ones means electrons embedded in it, like you fry your pancake and now put, you know how they do mishai, all those things. That's why they call it pudding, plum pudding. Just like you prepare your dessert. This is whose model? J.J. Thomson. So it means that the positive charges are scattered all over until alpha particle is of course helium nuclei. When they were struck against this, a thin gold foil was placed. That thin gold foil contains many atoms, and the alpha particles were short, projected to pass through. Most of them passed undisturbed. Assuming all of them passed undisturbed, then this theory is correct. But some of them will hit the particular that hit the thin gold foil and come back. How did they know? There is detector they placed. So it is not true. If these positive charges are scattered, they won't be thick enough to throw back helium. So it means that these positive things are concentrated somewhere called the nucleus. So the idea of the nucleus was created, not that the positive was scattered. This is where the positive is inside the nucleus, so that the negative will now be outside. So this is Rutherford's model, telling us more like cloud of electrons. You see it now, no more like this. So it was this experiment that led to the discovery of the nucleus of an atom by Ernest Rutherford. Okay. The next question says the atom of an element X is represented as Y and Z. The basic chemical properties of X depend on the value of chemical properties. Please, we all know what determines chemical properties. Atoms are made up of electrons, protons, and neutrons. The one that bears the chemical property are the protons. Protons. Why is hydrogen called hydrogen? Because it has only one proton in the nucleus. If you are doing experiments or research, eventually thinking you have discovered new elements, only to count the number of protons inside that element, you find it was 19. My dear, don't say you have found new element. Simply tell us I found potassium. So electrons are not the chemical identifiers. Neutrons are not. Rather, protons are. In other words, the number below this Z is called proton number or atomic number. Therefore, the thing that carries the chemical property of X is the Z, the number below, which is option B. All right. So because Z here represents atomic number, which we can also call proton number, but Y represents mass number. Mass number is the number of protons plus neutrons, while atomic number is the number of protons only. And I said that the particle that determines the chemical property or chemical behavior of any atom or any element is simply the number of what? Protons. So if you should see an element that have two protons only, it means that that element is nothing but what? Helium. So don't go celebrating you have discovered new element. No. So helium is helium, not because of the number of electrons it actually have, but because of the proton it possesses. All right. Maybe I'll give more light here. If we have something like calcium, 40 is up, 20 is down. This means 20 protons and how many? 20 neutrons also. If we have sodium, 23 and 11, it is this 11 that determine the chemical property. How many protons are here? Protons, 11. Neutrons is 12. Just say 23 minus 11. You get that. Electrons are also 11 because there is no charge. All right. So I hope we are making a progress. For you that those that are still online, give the live stream thumbs up. It's not a crime, please. Then share the video, like and share it. Get us your questions at Daily Science. I posted. Remember to join the WhatsApp +234 if you are coming after this stream. 65166 This is the number you have to chat to join the group, because before then we have every Fridays this live stream will occur in chemistry and in biology. So you always make yourself available. Today is the first day we are doing it anyway. So please share this. Before we continue, there are some fewer things we also need to know. All right. So
Majestic periodic table is here to rescue chemistry students everywhere. Struggling with the periodic table in classrooms, lecture halls, or laboratories? Worry no more. The Majestic periodic table has arrived to solve 90% of the confusion students face. This masterpiece behind me is not just a chart, it is also a summarized chemistry textbook packaged into one powerful table. Every element box contains at least 9 key facts, beautifully organized and easy to understand. And yes, it covers the electronic configuration of all 118 elements. The colorful design highlights important trends at a glance, making memorization almost fun. Yes, chemistry can be fun sometimes. It also teaches the basic rules and laws that govern how elements are arranged into groups and periods. So students no longer have to cram what they can simply see with their eyes. Now, here's the exciting part. You can customize your own copy with your name, your school or institution, a friend or loved one's name. Perfect for gifts. It comes in different sizes, different materials, and we deliver anywhere exactly how you want it. The most informative periodic table ever made is finally here. Get yours today and make chemistry bow for you.
Majestic Tutorials, your free school within school and after school, your complete online school.
Majestic Tutorials, your free school within school and after school, your complete online school.
Want to smash JAMB with a high score and earn straight A1 grades in all 9 WAEC subjects? Want admission into medicine and surgery, law,
Pharmacy,
engineering, nursing, architecture, computer science, accounting, dentistry,
medical laboratory science,
and many more lucrative university courses?
Then join Majestic Tutorials on YouTube and across all social media platforms today.
Enjoy world-class lessons in all major art and science subjects, completely free.
Delivered by experienced and renowned tutors. Don't miss our live streams, final revisions,
And exclusive study sessions. Call or WhatsApp +234 706 516 6217 to join now.
Majestic Tutorials, where champions are made the majestic way.
First, watch this advert. Buy from me, I equip laboratory, standard laboratory. I give you trusted reagents because I'm a scientist, equally medical equipment. Thank you. Your patronage is needed.
Looking for experts in building and equipping standard science laboratories? Need reliable surgical or hospital equipment? Easy World Science and Surgical Supplies Limited is your best choice for quality and excellence. We provide professional construction of standard science laboratories, high quality laboratory equipment and reagents, durable surgical and hospital equipment, timely delivery of exactly the quality you request, expert guidance to assist you with any experiment or equipment usage. Be scientific, stay safe. Choose equipment and reagents that guarantee results and protect your health. Contact Easy World Science and Surgical Supplies Limited today. Majestic, reliable, affordable. Thank you.
all right, welcome back. We are back. What we showed you there, we have the majestic periodic table, which will help you to learn. There is no table designed at that table. It's also available in sticker form. You can paste on your reading desk, even in your notes. But it's better enjoyed in a bigger size for schools, bigger institutions. Okay, I saw all over Nigeria. Okay, and then the other one is telling you that majestic tutorial. We are here. We are live streaming on chemistry. Soon we switch to biology. With time, we will live stream in all the major arts and science subjects for this UTME examination. And then lastly, I sell reagents as a scientist. I produce and sell. So you contact us. We provide all these services, build laboratory from the scratch to give you the best. Thank you for watching. As we proceed, we stopped at question number 8. Then question number 9 says, the diagram, I have to clean up this. Question number 9 says, the diagram above represents the electron sublevel for which element is this? Those that are live, sorry, I can't get your messages. It's not my fault. I don't know why, but I might maybe hotspot this device to check if live chat is actually possible. Okay, because I think that's what I'll do, the best thing to do, and connect this device to internet and log in also. It might lag this whole thing, but I think it's necessary for now. But before then, let me answer this number 9 in case of those that just joined. How do you know? They say the diagram above represents the electron sublevel for. Simply count these arrows inside. These are electrons. Okay, let's go. This orbital contains 2, is paired, so it becomes 2, 4, 6, 7, 8. And which element is number 8? You know your first 20 elements. Your number 8 is oxygen. So the correct answer is option C. Simple. Then the next one says, in the periodic table, electrical and thermal conductivity are properties of elements that electrical and thermal conductivity. Electrical, you know, how will you know that? It now boils back to that periodic table I'm talking about. When you move from the left to right, I think since you have the opportunity to join the live stream, I will also teach you with that majestic periodic table anyway. Okay, so permit me, I'm coming, be right back. Let's just search the table and protect some of the privacies of my gadgets. All right, here we go. I think it's visible now. So they are asking us electrical and thermal conductivity is a property that does what? Look at the majestic periodic table. Very detailed. All unique configuration of the whole element starting from number 1 to 118 is available, and each box contains not less than 9 information. You see, it contains the configuration. Krypton is 28188. You have the boiling point, the melting point, the ionization energy, so many informations. But let's focus on using it to answer that question. If you move over, here is the right, this is the right, which is the alkali earth metal and the alkali metal. If you move from the right to the left, you are moving from metal to non-metal. So that means this is across the period. So if you move from metal to non-metal, remember, metals conduct electricity, non-metals don't conduct. Therefore, when you move across the period, it decreases. Electrical conductivity decreases. But the same thermal conductivity and electrical conductivity also increases down the group. So just know that electrical conductivity decreases across the period. Reason is because across the period, you move from your left to your right. So across the period, moving from this particular left hand, to your right hand side. If you move from the left hand to right hand, you are moving from metal to non-metal. And metals are good conductors, non-metals are not. So electrical conductivity decreases across the period and increases down the group for metals. As simple as that. All right. So let's check options that match what I just explained now. In the periodic table, electrical and thermal conductivity are properties of elements that A, decreases across the period, fact, and increases down the group, also fact. But when option A is the answer and you still have time, check option B, C, D, so that you won't be deceived. Okay, increase across the period, no, it can never increase across the period. Decrease across the period, we are considering that fact. And down the group, no, it doesn't decrease down the group. Increase across the period, we have seen our answer. The correct answer is option A. All right, we move to the next question. which will be, I guess I will go back entirely to the album for JAMB live stream. All right, here we go. Remember, you are watching Majestic Tutorials, of course. The idea is to answer at least 500 questions before JAMB. We'll be doing this all every Friday, and we'll endeavor to handle at least 10 or 15 questions each day. All right. Let's see. We are at the first page. We move to the next, which is question number 11. Question number 11 says, the reaction above is an example of, is exactly 45 minutes, is already time, but let's try. The reaction is an example of, I hope the question is equation is clear on the screen. Please, this is sodium 23. Up here is 23, up here is 24, 11, 11. It's just purposefully changing one isotope to the next isotope. And when this happens, by bombarding it with energetic particle like neutron, we call it artificial transmutation. Don't call this thing nuclear fusion. No, it's not nuclear fusion. Remember that a neutron is not a nucleus. Single proton doesn't make up a nucleus. So when we say nuclear fission, the joining or combining of two lighter nuclei. But this is a neutron, just energetic particle. So we call this artificial transmutation. Reason, because we transmuted, imagine that English, we converted one isotope of sodium to another what? Isotope. It was Ernest Rutherford that carried out the first artificial transmutation, where he transmuted nitrogen to oxygen by bombarding nitrogen with helium. All right, which is the transmutation process. The first one was by Rutherford, and I said he was able to convert nitrogen by bombarding it with helium to oxygen to give us oxygen 17 and 8, then plus ejection of what? A proton. A proton is actually ejected. Transmutation. All right, so it is either that a neutron is absorbed or that a proton is ejected, depending on the stability of the on the size. For smaller sized atoms below 20, simply a proton is ejected out from the whole process. How do you check if this is correct? 14 plus 4 is 18. 17 plus 1 is also 18. 7 plus 2 is 9. 8 plus 1 is also 9. But when it is above 20, like as we can see here, it will just do what? Absorb the neutron to increase its mass. So when you bombard heavier atoms, if you bombard heavier atoms, you will only get the isotope of that atom. But when you bombard lighter atom, like in an artificial transmutation, you can convert it to another element. The ones that the mass number is less than 20, you will get new elements. Like the nitrogen was bombarded with helium and it was converted to oxygen. But when you come to sodium, for example, like what happened here, it only converted it from different isotopes of sodium. It didn't change the element. So the correct answer here is artificial transmutation. Now, air boiled out of water as steam is richer in air boiled out of water as steam is richer in what? Now, this is the point. You have to check the solubility of the components of air. Air is a mixture of gas, which are nitrogen by 78%, oxygen by 20 to 21%, carbon dioxide by 0.3%, and noble gases less than 1%, of course. Now, out of this, these two are the ones that are soluble at all in water. Nitrogen doesn't dissolve, noble gases doesn't dissolve. So when you boil air out of water, it will probably contain more oxygen and more carbon dioxide because they are the ones that are a bit soluble at all in water. And again, you should learn something. The percentage of oxygen in the atmosphere is 20 to 21% by volume and not by mass. But the dissolved air, that is air dissolved in oxygen, the percentage of oxygen, air dissolved in water is what we call dissolved air. You remember that air dissolves in water, that enables aquatic organisms to survive. So in dissolved air, it contains 33% oxygen. Note this, so 21 to 20% is for atmospheric air. But air that has been dissolved in water contains 33% of oxygen. That is the question they asked us here. We always learn the surface one, which is 21% of oxygen. You now forgot that inside water, that oxygen, in dissolved air, that oxygen is more than 21%. Why? Because nitrogen never dissolve well, and noble gases don't dissolve well. It is only CO2 and oxygen that dissolves. The next question says, in the course of purifying water for township supply, the water is passed through large settling tanks containing sodium aluminate. Sodium aluminate, that is alum. Sodium aluminate. In order to do what? To remove large particles, to remove germs, no, to remove fine particles, to remove odor. It is a coagulating agent, coagulant, and coagulating agents are to gather particles together to clump. When particles gather and clump, they settle at the bottom. Therefore, the correct answer is to remove large particles that cannot settle on its own, that is still floating, but need to be gathered around to settle. So it's unfortunate I was unable to receive some of your questions. Me personally, I don't like it, but it has been the way it is. For now, I could have said let me end, but let me do that thing I said I'll do, to hotspot this device and tune into the same network and check if I can see any of your messages. All right, we are back. Please share the video. Right, we are back. Please share the video, remember to come back next Friday. This happens weekly. All right, let me check if this is connected already. Why wasting time now? Things that connect automatically. Today now we are wasting my time. Okay, we now check YouTube. Any comments? Okay. No live chat anyway, so top messages. No. Okay, it's probably that those that are live were purposefully kept quiet and they are watching. No problem. Anyway, thank you guys. I've tuned into the live stream and nothing. There is no chats at all. At least I appreciate your silence anyway. So with this, I think we draw the curtain for today's live stream. In 3 minutes time, we are coming back for biology, the same channel, just in 3 minutes time. God bless you guys. Remember, 370 and above is the aim for holding these live streams.
Is here to rescue chemistry students everywhere. Struggling with the periodic table in classrooms, lecture halls, or laboratories? Worry no more. The majestic periodic table has arrived to solve 90% of the confusion students face. This masterpiece behind me is not just a chart, it is also a summarized chemistry textbook packaged into one powerful table. Every element box contains 9 key facts, beautifully organized and the electronic configuration of all 118 elements. The colorful design highlights important trends at a glance, making memorization almost fun. Yes, chemistry can be fun sometimes. It also teaches the basic rules and laws that govern how elements are arranged into groups and periods. So students no longer have to cram what they can simply see with their eyes. Now, here's the exciting part. You can customize your own copy with your name, your school or institution, a friend or loved one's name. Perfect for gifts. It comes in different sizes, different materials, and we deliver anywhere exactly how you want it. The most informative periodic table ever made is finally here. Get yours today and make chemistry bow for you.
Majestic Tutorials, your free school within school, your complete online school.
Majestic Tutorials, your free school within school and after school. Your complete online school.
Want to smash JAMB with a high score and earn straight A1 grades in all 9 WAEC subjects? Want admission into medicine and surgery, law,
pharmacy,
engineering, nursing, architecture, computer science, accounting, dentistry,
medical laboratory science,
and many more lucrative university courses?
Then join Majestic Tutorials on YouTube and across all social media platforms today.
Enjoy world-class lessons in all major art and science subjects, completely free.
delivered by experienced and renowned tutors. Don't miss our live streams, final revisions,
And exclusive study sessions. Call or WhatsApp +234 706 5166217 to join now.
Majestic Tutorials, where champions are made the majestic way.
First, watch this advert. Buy from me, I equip laboratory, standard laboratory. I give you trusted reagent because I'm a scientist, equally medical equipment. Thank you. Your patronage is needed.
Looking for experts in building and equipping standard science laboratories? Need reliable surgical or hospital equipment? Easy World Science and Surgical Supply is your best choice for quality and excellence. We provide professional construction of standard science laboratories, high-quality laboratory equipment and reagents, durable surgical and hospital equipment, timely delivery of exactly the quality you request, expert guidance to assist you with any experiment of equipment usage. Be scientific, stay safe. Choose equipment and reagents that guarantee results and protect your health. Contact Easy World Science and Surgical Supplies Limited today. Majestic, reliable, affordable. Thank you.